we get started on the first part here, I'll just make mention that I think there's something missing from part 2. We've got cross sections of where this region right here is the base of the solid are perpendicular to the y-axis, but we're not told what kind of cross sections they are. Are they squares, rectangles, semicircles? So we can't really address this one. But anyway, here is the graph of y equals 1/2 x squared, this parabola, and the line y equals x. You can see that those two graphs intersect at 0, 0 and 2, 2. And we want to revolve this gray region around the line y equals -1. Using both the washer disk method, in this case it's a washer method, because there's an outer radius and an inner radius. And when you're doing the washer method, you want to visualize typical radii that are perpendicular to the axis of revolution, and then use the definite integral from 0 to 2, and that's this 0 and this 2, because we're integrating along the x-axis, of the outer radius squared minus the inner radius squared. Well, the outer radius is the distance from the axis of revolution to the a point on the graph of the high function. So the y-coordinate of this point right here is x, because this is the line y equals x. So for each x, this height right here is x, and that's the y-coordinate. So the total distance is top minus bottom. X minus a -1 is x plus 1. There's the outer radius squared. The inner radius will be the distance from here up to this point, which is 1/2 x squared for a y-coordinate. So this total distance, the inner radius, will be 1/2 x squared minus a -1, or 1/2 x squared plus 1. Whoops, I forgot to put a square here. Inner radius squared. Okay, so if you had to actually evaluate that, you'd square this binomial, combine similar terms, find an antiderivative, then integrate from 0 to 2. On board 2, we have the same graph, but now we're going to use the shell method. So in the shell method, our typical height of a shell is parallel to the axis of revolution. So we need everything in terms of y, because we're finding x distances. So it's obvious that if y equals x is this line, then x equals y. But down here, we would like to find x in terms of y, because this is a horizontal distance. So if we solve this for x, we get plus or minus the square root of 2y, but the positive square root is what takes us from here to here. So for each y, this distance right here is the square root of 2y. Okay, so for the shell method, it's 2 pi times the definite integral from 0 to 2. That's, in this case, this 0 and this 2, because we're integrating from here up to here, of the distance of a typical center of the shell, which we're just going to use this y value right here. I'm sorry, yeah, that y value right there, minus a -1. That's this blue distance right here. So there is the typical radius from the axis of revolution to the center of the shell. And then times the height of the shell, which is this distance right here. So we have to take this x coordinate and subtract this one to get that little distance right there. So that's what this is, the height of the shell right there, radical 2y minus y. So both of these integrals, definite integrals, will give us the same value for the volume of the solid revolution. And I will hope that helped. And if you have any questions, post a comment.